Ooh, people are here. Good job. So definitely several people ask me about theoretic exam. I did mention in the announcement that if your exam is better than any of the midterms, we will use that exam, final exam grade, to put on top of the bad midterm grade, but not the other way around. You cannot push final exam up. Let's go to resurrective final exam because it's like last chance to save your grade. There are 10 multiple choice questions. And then a lot of grading from my side will be 1 and 2. Also, technically speaking, it's so totally 16 questions. So 16 minus 10 is 6. But they have ABCs. So kind of not really, especially derivatives, final derivative of this one, final derivative of that one. Final derivative is implicit differentiation. That's like ABC in one question, but it's 3 questions. So they made it long. I can see that, but luckily we have 2 hours. I will give you full 2 hours. Don't worry about this, because technically speaking, it's hour 50 minutes. Elasticity of the demand, integration is there. A, B, C, find the integral, and so on. And of course, surplus. That's the last chapter we covered, so it's also there. Let's do it. Let's review everything and everyone and everything we need. Let me open. Post your questions in the chat. I'll be checking from time to time. And it will be nice. I'll be stopping from time to time. Final exam review. So I'm grading my other final exam right now, which I had on Tuesday. And tomorrow we can have ours. Share the screen. Some questions in the chat. I will see whatever I can fit in 2 hours, because I need to go in 2 hours. But I think I can review everything. I will let you know when we finish how good it was. I'm also curious. Share the screen. Here it is. You guys see the screen and you guys see the writing and me. Okay, good. Chat, I see the chat. Yes, I have exam since forever already. They gave me exam, I think, on the weekend. So, and I changed it a little bit. So it's a bit better than it used to be. And I put some formulas for you. So I put an announcement what formulas is there. Exam will be around everything. Exam review will be around everything because everything is on the exam. I can't tell exactly what's on the test, but it kind of has everything. For example, let's start with limits. Also, the last quiz I gave you was actually really good. I guessed. It was a very good guess what will be on the test. So I gave a very good quiz. But if you remember, we started with limits and continuities. That was exam 1, continuities. So in your quiz, last quiz, check that one out. Quiz 9, how did you do on that? I gave you some things to practice. And that's good. If you are confident with that, it's good. But remember, you need to be good with quadratic equations because some of you are not good with quadratic equations. And sometimes factoring is a big deal. So, for example, limits, for example, the one from the quiz 9, and I will just give you one more example, like this one, 3x squared minus 9, 6 minus 2x. So it is 0 over 0 case. You check that. You need to know standard formulas. X minus 3 times x plus 3 all over 2, 3 minus x. Almost matches. We need to get rid of the troublemaker in the denominator. So I'll change the sign somewhere. Doesn't really matter where. For example, I'll put minus 2. That will be x minus 3, x minus 3, x plus 3. Since x actually never reaches 3, we can cancel out these because we're not dividing by 0. It's not 0. And our limit ends up to be x plus 3. We just plug in. 3 plus 3 gives you 6. times over minus 2. That is minus 3, correct. So review these kind of things. Limits, review quadratic equation. So I would, if I were you, I would review factoring. That's what I just did right now. I would review quadratic equations. That's the one they like to put in a test, quadratic equations, which is what x squared minus 3x plus 2. How can be written as what? You know, x minus 1 times what? And so on. So review that, those things. I have actually videos on these from my college algebra class. Kind of that's good enough. And then infinities. Infinities. Let me take these examples. Oh, yeah. Limit at infinity. Find the leader of the top. 5 minus 8x squared. 7 minus 9x minus 4x squared. Find the leader of the top. Minus 8x squared is the leader of the top. Minus 4x squared is the leader of the bottom. Now you're kind of comparing these two only. Because others are just tails. They're following the leaders at infinity though, only at infinity. So cancel out, cancel out. It ends up to be minus 8 over minus 4, which is 2. In general, if powers matched, the answer will be the ratio of the leading coefficient. The ratio of the leading coefficient. If the top wins, then the answer will be infinity. So if it's 4 minus 8x squared over 2x plus 6, the leader of the top grows to infinity faster than the leader of the bottom. So the answer will be plus or minus infinity in this case. So you need to figure out which one in this case. Minus infinity times, no, infinity times minus 8 is minus infinity. So it's going to be minus infinity. That's all. Finally, if the bottom wins, then you're dividing by the huge numbers. 4 minus x minus 8x squared, 5x to the 7 minus 3x. X goes to infinity. The denominator explodes to infinity super fast. So you have a case, a number over infinity, dividing by the biggest numbers, you know, get the smallest numbers, you know, so that is 0. And in this case, you had infinity over number, plus or minus. That's how we were learning it, remember? Kind of, this is all you need to remember from limits. At least algebraic limits. See the question? Negative infinity because minus 8 was multiplied by plus infinity. So it was like this, minus 8 times plus infinity. That is minus infinity, like so. You can also check it with huge numbers. You can put some million in 4 minus 8x squared over 2x plus 6, and it will give you negative and huge numbers. That's how you know that you're correct. That's how you can check actually your calculations. You can always put some huge, you can check by plugging huge numbers in all of these, even in the previous ones where you have to factor in stuff. So if you plug huge numbers, it should give you something like minus 2.9999. And that's how you know that you are correct. Oh, not huge numbers. In this case, you could need to plug something close to 3 to get that. And then in these cases, you need to plug something huge because we're going to infinity. So those are infinity cases. Infinity. Limits at infinities in infinite limits. Now, there's kind of no left limit or right limit on the test. We already covered it in the first exam, so we don't really need that. But we slowly moved from there to continuity and average values, and from there to derivatives. So continuity had a formula that left limit should match or meet with the right limit. And f at that point. So it was limit from the left, x approaches a from the left, f of x equals limit from the right and f at a. That eliminates any holes. That was the definition of the continuity. Or in general, you don't take the pencil out of the paper for the function to be continuous. And then from there, we learned average rate of change and instantaneous rate of change. That slowly takes us to derivatives. So average arc, average rate of change versus instantaneous rate of change, which is derivative. Let's check that. Here is an example for you. You had this on exam 1. There was a graph like so. Here's the graph from -7 to 3. And then we can ask you lots of questions. So let's review that. What is happening with the derivative at -2? What is derivative at -2? Do you remember? If you reach maximum or minimum, derivative is 0. Also, before minimum and maximum stuff, we were explaining you that it will be horizontal because it was increasing and then was decreasing before and after. The floor has 0 steepness, and that's why derivative there is 0. Derivative at -2 is 0. Derivative is 0. Same over here. Derivative is 0. Same over here. Derivative is 0. Before that, so what is happening at -3? Derivative at -3 is positive because you see we're climbing up. Derivative is positive. At -1, derivative is negative because you're climbing down. Derivative is negative, like so. Going up, 0 derivative, going down. So increasing, maximum, decreasing. You remember derivatives, right? And now, no, I cannot take, I want to do the average. -2, yeah. For the average, let's make this to go higher. Like so, to 4, yeah. Then we'll taught you average arc, average rate of change. Average is not the derivative. Average was y2 minus y1 over x2 minus x1, while derivative or instantaneous rate of change introduced limit to this and says, you know what, let's make denominator as small as possible. So x2 was approaching x1 or x1 was approaching x2, but you don't do it in the denominator. You do it like this. X2 approaches x1. There was another formulation with h. Remember? Definition of the derivative. And when we were doing derivatives by definition, thanks God, we don't have this on the final exam. I hate that problems when they ask you to find what is x squared prime using definition of derivative. It was so annoying. So fx plus h minus f of x divided by h, where h shrinks to 0. That gave us an instant change because denominator kind of represents change in time or change in input. So when this change in input is instant, that gives you instantaneous rate of change. So we just reviewed how to identify derivatives, signs, and stuff like that on the graph without a given function. How about arc? Take a ruler, and I will ask you, actually don't take the ruler yet, and I will ask you to find what is arc, which is average rate of change over, and now like -7 and 4, right? So you can do it either approximately or exactly. Arc checks the height. Basically, arc takes the average slope. Put it in pink, for example. This is the average change. So you was hiking down, then up, then down, then up. what was your average change of the elevation? This is arc. This is called secant line, but it has more properties than just a secant line, but it is a secant line connects to points on a graph, but it is average rate of change from -7 to 4. So this is the slope. The slope of secant line here is positive. The slope is positive, so you can make a claim on average. Your elevation increased on this hike, even though at some point you were going down. That is the idea. And now a question for you. So you can calculate it if you want, if they are ever asked you to calculate exactly. You need to know those points. So the first point is, for example, 4,5. Let's call this 5 height. And the other point is -7, 0. You take outputs and you always do the next one minus previous one. The next output is, the next height is 5 minus previous height 0. The next input is 4 minus previous input -7. We expect it to be positive because, as you can see, the average line is going up. The steepness is increasing. And indeed, it is 5/11, like so. Positive, like we expected. y2, this is the formula I used, y2 minus y1, x2 minus x1. Like so. Let me close the browser. I already can see it's slowing it down. So, good. And then last question, which we had in exam 1 was arc. And the last question, remember, it was like true, false stuff. So is f, so who is bigger? F prime at -3 or arc on the whole interval -7 and 4. We want to know what was better, a bigger change of elevation of this hike on average or at specific point. F prime at -3 is this one. See how steep it is? That is definitely steeper than this one. So at that moment, it was very complicated hike. You had to like stop many times and rest. But on average, you actually did not hike that much. That is the idea. The elevation was not that changed on average. So that is the idea. Let's see. Do we need to know the limit equation for the rate? Yeah, I just mentioned it, so yeah. Will we be tested on that formula? Maybe. What would the derivative not be 0? When derivative would not be 0? Everywhere else except the hills and pits. Yeah, good questions. So remember that. Do you need to know? You need to know the definition formula. Definitely have this formula. This one in green. So this is important, arc and derivative. Now moving on. Let's see. What else? I'm following the chapters. The questions, is this function continuous or not with the system? And it was piecewise function. Yeah, I did not put it there. No graphs, left and right, in limits, not either. Do you know how to find the average rate of change from the table? So I showed you how to find it from the graph, but do you know how to find from the table? Like so. Still arc. So we learn how to find arc from the graph. y2 minus y1 over x2 minus x1. And we know how to do it using the ruler, right, on average. But how about the table, remember? So there was like, we give you input, 1, 2, 3, 4, 5, 6. and the output 620 minus 3, 8, 12, 1.7, whatever. That is f of x. And they somehow backstory, calculate the average rate of change of the given function over the interval and specify the units of measurements. One is like days, the other one is dollars, whatever. Some kind of backstory behind all of this. So find arc over, and you need to know any kind of interval. I was like very random right now. For example, from 2 over 2, 6. Okay, now you get your red pen or whatever and find the 2. Here's a 2, find the 6. Find the output, input, input, output. The formula says, like here, change in output over change in input. It's like, what is the average of your exam grades? You take output first, that is all the exam grades, and you divide by the number of exams. So you see output over input, time, or how many exams you had was input. So solution, you will take 1.7 because that's the output, minus 20, always do next one minus the previous one, 6 minus 2. Kind of that's all, that's what you need to know. So it's going to be minus 18.3, right? Over 4. And we expect it to be negative because it was 20 and then became 1.7. So like, duh, it definitely decreased. So on average, something decreased. You see, that's how you know that it was going down. How about, let's do one more. Over 3 and 5. Very quickly find maybe a marker. 3 and 5 minus 3 and 12, corresponding inputs and outputs. 12 minus 3 over 5 minus 3. Well, from minus 3 to 12, it's increased, right? So I expect it to be positive. That is true. 12 plus 3 is 15 over 2, positive. And that's how it matches the explanation I gave you before, graphically and just intuitively. Average rate of change is positive or negative. No piecewise functions on a test. So that's good. After this, we can go to derivatives. What do you think about this? Dun, dun, dun. Limits and stuff. And derivatives. That has lots of stuff to cover. So let's move on. And from this, we introduce instantaneous rate of change. And from this, we introduce derivatives. And lots of rules, and then lots of applications. So definitely you need to be good at differentiation. Change rule is there and stuff like that. Let's practice that. And let me merge several problems into one. For example, you remember there can be more than one derivative, right? Oh, practice power rule, product rule, quotient rule, and then your favorite, chain rule. Yeah, it's I definitely claim that chain rule is not easy, so you have to practice it a lot. I gave exam in my calculus 2 class on Tuesday, and we're doing high-level math there, and they messed up chain rule, which we learned last semester. So it still hunts you. In next class, it will hunt you again. So you need to be good at this, but it's just lots of practice. For example, example 1. 8 over square root of x. Remember, I put it on the quiz and we added on the test. Prime. How do you do that? If you're not sure, first rewrite it as 8x to the minus 1/2 minus 4 of x to the minus 1/2. Now, make sure you sleep enough before the exam because your brain should not think it's logarithm over here. It's not integration. It's differentiation. So we're going back to differentiation. Make sure that your brain knows which one we're doing right now. 8 times negative 1/2 goes down. X minus 1/2 minus 1 minus 3/2. plus 4 x to the minus 2, and that is the answer. I specifically said on the exam, do not simplify. But what I ask you is to plug the number. So plug x equals 1. That's just because it's easier to grade this way. Will be 8 times minus 1/2 times 1 plus 4. That's 4. And calculate whatever it is. Minus 4 plus 4, by coincidence, it is 0. I just kind of randomly have. So that was just power rule, nothing else. I will not practice quotient rule and product rule. So you do it by yourself, read it many, many times. And kind of expect you to do really good on those problems. And also derivatives of logarithms and exponential functions. So let's do chain rule and stuff like that. 2. For example, square root of x plus, no, oh, actually it's fine. Square root of x plus x squared times e to the 3x plus 5. Let's practice quadratic rule after all. Y equals, find y prime. Okay, if you don't like square roots, write it down as x plus x squared to the 1/2 e to the 3x plus 5. You cannot simplify 1/2 and the square. Remember, there's no rule to do that because the square root cannot go down to like things. It has to stay there. There's no formula for the square root to go down on each term. So that's the problem. It's not square root of 1 and square root of x. It's not. You cannot do it this way. So let's differentiate. That is product rule. Product rule. Derivative of u times v plus u times derivative of v. Derivative of u requires chain rule. 1/2 goes down. Copy x plus x squared. Change the exponent. Minus 1/2. 1/2 minus 1. Times the derivative of the function inside. 1 plus 2x. Chain rule. And that is only u prime. Copy exponential function e to the 3x plus 5. That is times v. Plus, not enough space, moving down. Copy u, x plus x squared. I'm going fast on purpose because we did it before. So your job is to reflect. Is it easy for you right now? Can you catch up? Are you faster than me? Or you don't remember this at all? If you're not remembering this at all, put some note and review it. You still have time to tomorrow. And if you're good at this, concentrate on something else like implicit differentiation and so on. So it's more like a reflection review. You should just don't reflect on yourself. Derivative of e is e. Copy the whole thing. And then times the derivative of the function inside, which is 3x plus 5. So it's times 3. Do not simplify. Plug the number I give, whatever the number is. That is the answer. What do you think about that? Checking chat. Yes, this is it. So it is product rule and chain rule and exponential function. Ask me, like this is a good moment to ask. Don't be afraid to ask. Lots of those things were old, so we might not remember this. Where did you get 1 plus 2x? So derivative of the function outside times derivative of the function inside. And the function inside was x plus x squared. So that is 1 plus 2x. Why do you multiply by 3? Derivative of the function outside, e gives you e, times the derivative of the function inside times 3. Oh, why did it go away? Okay, maybe this note will help. U times v prime. So product rule. 1/2. Looks good to me. Let's see. This was u prime using chain rule. Copying v. Then I'm copying u, and then it's v prime. Does it make sense? Which one go away? So like you should tell me. u prime v plus u v prime. Okay, now let me know if I did not answer the question. And don't be afraid to unmute yourself. Yeah, so let's see. This will be on a test, like definitely practice that because they want to make sure you guys are good with differentiation. I think from my point of view, what they're doing as a department, they're trying, this is the last chance to filter students who are not good with differentiation and fail them. Because I can see lots of differentiation on the test and integration. So I think that's what the idea behind it. So make sure you practice a lot. Let's do implicit differentiation. Oh, and logarithmic function. Let's do logarithmic function. We did not do that yet, which is x, and let's do quotient rule, and why not? Plus square root of x divided by ln 3x squared. Yeah, I just made up some. Y equals, check this out. Derivative, I will jump into derivative right away. Check this out. This is u over v. Do you remember the formula? Quotient rule, v squared. Start with that because then you will not forget to do. Now, we don't need to simplify. I will ask you on a test to plug the number instead, like plug 0 or plug 1, whatever I chose. That will help it to grade faster. Derivative of uv minus uv prime, order matters. So remember how the order looks like. I always start with differentiating with u in both formulas. That's easy to remember. So square the denominator right away and just don't touch it. ln 3x squared squared. Boom. No need to simplify that. We never ask you. Derivative of the numerator is x gives you 1 plus square root of x gives you 1/2, x to the minus 1/2. Just practice separately. X to the minus 1/2, and that's like that. Many people just remember it. Derivative of u, then copy v, copying ln 3x squared minus copy u, x plus square root of x times derivative of v, but v is a logarithmic function. Derivative of log is 1 over everything inside. So it's going to be 1 over 3x squared, remember, times the derivative of the function inside, which is 6x. That is the answer. So this was v prime, and this was u prime. About that. Am I recording? That's very important. I decided to check. Yes. Okay, let's move on to implicit differentiation. That is important to do. It was your favorite problem on exam, maybe. Oh, and application. So if I ask you, let's do the implicit differentiation, and then I will jump to applications, which are marginal, velocity and acceleration, those kind of things. Implicit differentiation was exam 2, which is always the hardest one, remember, because it had lots of material. Derivative of logarithmic functions, exponential functions, and then implicit differentiation. I decided to tell you on exam, use implicit differentiation here, so you don't have to guess. Implicit differentiation. Remember, when we don't have the case y equals blah, 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 then we don't do differentiation explicitly, we do it implicitly. And that is the case, for example, 6x squared. Y equals y squared plus 15x. Something like this. Let's do -3, which doesn't matter because it will be 0. Solution. Differentiate everything you see, keeping in mind, every time you differentiate something with y, y prime shows up. So, product rule, for example, like so, 6x squared times y, u times v. Derivative of 6x squared is 12x. Copy y plus copy 6x squared times derivative of y, is y prime. So every time you differentiate something with y, you put y prime or dy or dx. You decide. Equals derivative of y squared is 2y times y prime. Yeah. Derivative for 15x is just 15, and derivative of -3 is 0. Your job is now to move things that include y primes to the left-hand side, or just one side. And you can use right-hand side if you want, or some students do actually. Doesn't matter. 6x squared y prime minus 2y y prime equals, and move everything else to the right, 15 minus 12xy. Step 1, differentiate everything. I gave you steps, remember? Step 2, move things around. Important things to the left, not important things to the right. Important things is the one that involve y prime. Factor it out. Y prime, brackets, open the brackets. 6x squared minus 2y equals 15 minus 12xy. Last step gives you the answer. Divide right-hand side by the brackets. Y prime will be 15 minus 12xy all over 6x squared minus 2y. That is the answer. Right-hand side over those factored out brackets. The goal is to isolate y. So question A. Find dy over dx. We did that. That is y prime. Question B. Find y prime at the given point 1, 0, for example. You plug 1, 0 into here. Be careful. Take a pencil and write down x is 1 and y is 0. Now you can visually plug it in carefully. It's going to be 15 minus 12 times 0, 6 minus 2 times 0. So the answer is 15 over 6, which is 5 over 2. But it doesn't matter. Whatever. Okay. Can do that. Implicit differentiation. So let's see, there's a good question here. On the left side, you differentiate it and then copy it how it originally was. Oh, I know what's the question is, but I think I know what's the question. This was product rule. U times V. U prime V plus U V prime. Right-hand side also differentiate, but there's no product rule on the right-hand side. Y squared gives you 2y times y prime. 15x gives you 15. Does it make sense? So be careful. It might be quotient rule, product rule, and stuff like that. You have to carefully differentiate. So 6 squared y prime is not 12x y prime. You cannot just differentiate piece by piece. You have to use product rule. Product rule. Yeah, do you want x over dy? No, we will not ask you to find the x over dy. Actually, in 211, we probably will, as I remember, unless they changed. So, implicit differentiation. After this, let's do some things like that. For example, check this out. Example, find acceleration. Acceleration if position is given. Position is s of t equals x minus x, natural log of x. Check this out. Do you remember the relationship between s, v, and a? Position gives you velocity. Velocity gives you acceleration. Taking the first derivative and then the second derivative of the position, or the first derivative of velocity, gives you acceleration. That is important, so remember that. And remember, marginal means derivative of stuff. So we need to differentiate twice to get acceleration. S prime of t equals 1 minus, and then I have product rule one more time. U times v, that is product rule. Derivative of x is 1, copy ln x. So open brackets because of the negative sign, be very careful with that. Plus copy x times, what is derivative of ln x? 1 over x. That is the first derivative of the distance or position. Let's simplify. 1 minus ln x minus, because negative sign have to be distributed. X cancels out with 1 over x, gives you 1. So actually it's not just 1 minus 1. Minus ln x. That is velocity minus log acceleration is v prime minus 1 over x. Boom, done. So that is important. Very tricky way to check if you know product rule and quotient rule or chain rule is to put it in this kind of wordy problem. Hey, find marginal of the profit, where profit is this product rule, quotient rule, or exponential function. Hey, find acceleration or velocity, where the position is this. So be prepared for that. That's one more problem that asks you to differentiate, basically. More stuff. After that, we learn increasing, decreasing stuff, maximum and minimum stuff. And we learn different things. We learn a lot of stuff after this, related rates and stuff. So let's do that. So applications, maximum and minimum values. Remember, there were several. They were extrema. They were a relative minimum and absolute minimum, right? So there's a relative versus absolute. They all called extreme values, extrema, extreme values or extrema. So if you see any of these words, I just put min-max for you, and I put either absolute or relative, so you can see it. But it's from English point of view, you should know all of these mean the same thing. Global, absolute, the biggest one, the smallest one. So those kind of things. Min-max. So let's do it. From the graph or from the function. It has a relationship. It has a relationship with critical points. Example. That's from the review number 7. So f of x is 8x cubed minus 24x plus 12. A, find, let me see how I should explain it better. Okay, 2 ways, 2 things to find, and they are different. Let's do global first. Global, find. Global min-max, absolute extrema. See, they're called absolute extrema. 1 minus 3, 2. There's a theorem that says on the closed interval, this continuous function will definitely have maximum and minimum. So on the second exam, some of you said there was no maximum and no minimum. Yeah, that kind of contradicts the whole idea of the theorem. This is a continuous function. It is trapped. It's continuous. It is trapped on the closed interval. It has no choice to have minimum and maximum somewhere because it doesn't jump away to another dimension, seriously, and then so on. So this will be learned in upper level classes. Well, what happens when it does jump? But it's continuous and in the closed interval, it should have minimum and maximum. And you have several candidates for that. You definitely need to check endpoints. Maybe it's there. And to check those hills and pits, which are critical points, How do we find critical points? Setting a derivative b equal to 0 or d and e. Solution. Steps. That's the one with a table, remember? Table. Or the way you organize the information doesn't matter, but it starts like this. Step 1, you always start with finding first derivative, 24x squared minus 24. Set equal to 0 or d and e. It can be d and e, it's continuous. Solve for x. X squared equals 1. X equals plus and minus 1. See? Step 2, kick out extras. Both are in the domain. Domain is 3 and 2. You should not include anything outside of the closed interval, switch out. So if there's extras, kick them out. There was an exam 2, remember there was an extra root. Extra roots, yeah. So then both can be now called critical points. Critical points, critical values, blah, blah, blah. Step 3, build a table. Compare the values f of 1, f of minus 1. That is how high and how low the function gets at the critical points. And then compare how high and how low it gets at the end points. Remember that? That's it. Find the biggest one, find the smallest one. This is A, this is B, critical point, critical point. There's no other things to compare. Go back to the previous function and plug in 24 minus 24 because we plug 1, gives you 0. 24 minus 24 gives you 0 because minus, oh, I'm plugging into derivative. Yeah, it's not that simple. Plug into the original. 8 minus 24 plus 12 equals minus 12 plus 8, 4. And then plug minus 1, minus 8 plus 24 plus 12. 36 minus 8, 28. Plug 3, yeah, I definitely don't want to calculate that, and plug 2. And you will have some kind of numbers. Actually, at 2, I can see the answer. F at 2 is 28, and F at minus 3 is minus 132. Choose the winner. The winner is the one that has the smallest value and the biggest value output. So the minimum is this one, the negative wins. Thus, minus 3,132 is my global minimum. And it's also on the left endpoint. Nice. What is the biggest value? There are 2 winners, 28 and 28 were found with 2 inputs. Minus 1,28 and 2,28. Those are 2 global maximums. Like so. That is the answer. Check the answer questions. Can you do another one like the one you just did for velocity without ln? Maybe at the end, if we have time. Remind me, yeah, after 2 hours if we have time. Do we need to set it to DD on the test where with the both global maximum and relative? Will there be both global maximum and relative minimum? You should know both. So I will do relative right now. So DE on a test, I decided to give something typical, something like polynomials. So polynomials are continuous everywhere. That's why there's no D and E. Basically, D and E points are coming from denominator being 0 for these problems with teaching. And that takes too much time in the test. So I did not give anything like that. Let's see more. Let's go and check out different topic, which is, this was global. Global maximum and minimum example. Now let's do local. Local. Mean, max. You can even use the same example, or you can use different example. Doesn't really matter. For example, critical points. Let me see something interesting. Increasing, decreasing. Oh yeah, increasing, decreasing, those kind of things. Local maximum, local minimum. This one is good. Quadratic formula and stuff. Well, why not? Let's do that. F, well, it's K, but whatever. F of X, example, equals 4x cubed minus 24 x squared plus 36x minus 20. Find a local mean, max, B, increasing, decreasing intervals. Yeah. Solution. Start, step 1. Always start with the derivative, 12x squared minus 48x plus 36. Find a derivative. Step 1. Step 2, find critical points. Z equal to 0, that's a quadratic equation. You can divide by 12 here. It will be x squared minus 4x plus 3 equals to 0. Divide by 12. So it became a little bit easier. Review how to solve quadratic equations, either using quadratic formula, quadratic equations. So, or you know how to break it into x minus 1 and x minus 3 equals to 0. Everyone learned differently, but technically speaking, everyone is using Vieta theorem, but some of you are using a table and so on. I saw it in the exams. All of them are fine until it works. Quadratic formula always works. So just do quadratic formula. If you're panicking, have like this blurry mind, quadratic formula always works. 3. Well, that means x equals 1 and x equals 3 are critical points, right? And now for the local minimum, local maximum, increasing, decreasing interval, you perform a first derivative test. First derivative test, like so. I was teaching you with a sine line, f prime sine line or y prime. That is a line that has signs for the first derivative. That's what's called first derivative test. Put your critical points in order. Then take the test points on each interval and check the sign of the first derivative by plugging the test points into the derivative, not the original function. That's why it's called sine line first derivative test. So first derivative test, plug into the first derivative. And that's why I like this notation. It reminds you where to plug. Plug into the original one, not the one divided by 12, because it will change the sign if you divide it by minus 12 or stuff like that. So it is plus, if I choose 0, right? That gives you 36. Doesn't matter if it's 36. What minus? It's positive. Let's choose 2. That's an easy number. Apparently it is minus. And then let's choose like 100. I like choose geometric numbers. I can see that square makes it so big that minus 48x is not big enough. So it's going to be positive. Oh, actually, I think it's decreasing. Yeah, it is negative. Interesting. Okay. Let me check. Decreasing on 1, 3. Increasing to infinite. No, it is positive. They're wrong. Yeah, I just checked my mind. Because x square rules, it definitely picks it up. Increasing, decreasing, increasing original function. Original function has local maximum here and local minimum here. Local maximum, local minimum. Write it down. When the sign of the derivative changes, your original function has local maximum, local minimum. So, conclusion. F is increasing on minus infinity to 1. And then it is also increasing from 3 to plus infinity. Decreasing on 1 to 3, where the first derivative is negative. Local maximum is happening at x equals 1. And sometimes we ask you to plug it back in to know how high this maximum is. Local minimum at x equals 3. To find how high and how low they are, you plug into the original function. Original. That gives you f at 1 and f at 3. That gives you the height of the mountain and the depth of the pit. relative maximum is -4. It's even negative, okay. And the relative minimum is -20. Oh yeah, it's still lower. Local maximum looks like this. Local minimum looks like that. How about that? What do you think about that? Well, let me see. So the first question is how to know when it's local and not absolute. By my writing on the test, I will put it there. I already did. I put it there telling you global means global. And now it's supposed to click like this is the table one, the one where you build the table. Local is the first derivative test. Find local. Then it's the first, where is it? First derivative test. Like so. That's the difference.
Would you mind going back down to step 5? Sorry.
Yeah.
And then how did you determine if it was going to be going up before 1 and then down between 1 and 3 and then up afterwards again? How did you?
Yeah, I will explain this. That's a good question. And there's also a question in the chat. So you take test points from -infinity to 1. Take anything. You can take -1 million if you want, but 0 is like the best choice ever. If you have a chance to take 0, take 0. Plug it into the derivative. I put it in the box for that purpose. And then I was like, okay, 0 minus 0 plus 36. 36 is positive. So I put plus. Take a number from 1 to 3. You can take like 1.17, but why would you do that? Because 2 is easier. I took 2, and it was 12 times 2 squared minus 48 times 2 plus 36. I took a calculator, and it ended up to be negative. I just checked the solutions because they're in front of me. That one ended up to be negative. So I put minus sign. And then I took 100, and this one actually is a good one because 12 times 100, that's going to be 10,000 because 100 squared. Minus 48 plus 36. Like, there's no way that this number will be not the biggest one. So definitely everything will be positive. And that's why I like to choose like a million or something to see where it's all going. Does it make sense?
Okay, yeah, that makes sense.
Yeah. And then there was a question, why did you divide by 12? You don't have to. If you don't divide it by 12, then it's kind of hard to find the roots. So you write down the equation. Let me show you this. Equals to 0. And then I was like, I can see the relationship that I can divide by 12. And it's just nice. Now it's nice looking quadratic equation, but you don't have to. You can keep it as it is and then use quadratic formula. But if I divide it by 12, I could do this. Without dividing by 12, it would be hard to guess the roots. The answer will be the same. Good questions, people. Good job. This was some of the applications, and that's like lots of practice for problems. We had them on the exam too. True or false, relative minimum, increasing, decreasing, decreasing on the interval, increasing on the interval, those kind of things. And then the applications. Maximum profit, find the maximum profit, maximize the profit, minimize the fans, those things. Let's do that. Applications. Double P. Yes. I don't teach in the evenings for a reason. So let me know if I mess up. Applications of the derivatives. So application to maximum and minimum. It's called optimization chapter, right? Optimization. Let's go to real life problems a bit later. For now, just something simple like examples. Maximize or minimize profit. Or revenue. Revenue. See, I always stuck with this. Revenue, yes. Cost, profit, those things. So we had several kind of questions. For example, remember a relationship. No, that's not like example. It was an example, but it was like a chapter, the whole idea, right? So 1. Remember, profit is revenue that makes you happy minus cost that makes you sad. That's like basic knowledge. You will need to have that. If we give you revenue and cost and ask to maximize the profit, you need to first find it. Then we taught you relationship between, there was like average cost. I'm not gonna put it on the test. Way too many people will mess up. Average cost was cost over x. That's called average cost function. But we did that, remember? Then one more formula we need to know is how to find revenue from the Q and P. Revenue is quantity you are sold, say lemonade, you were selling lemonade, how many cups of lemonade times the price you charge for each cup. This is how much money you made. So know this formula. Q is quantity, P is price. And then after that, you know, just recently we learned elasticity formulas, and even more recently from integration, we learned surplus. All of this was connected. So this was like very, very beginning of all of this. Examples. If I give you profit, and no, if I give you R, 68Q minus 0.1Q squared, and if I give you cost, 23 plus 20Q, can you maximize profit? So remember these types of problems, solution. I don't see even the profit function yet, so I need to first find it. Happy minus sad, revenue will be 68Q minus 0.1Q squared minus, I'm asking you, put parentheses. You keep messing up the signs on the test because you're freaking out. Put parentheses, it will save so many mistakes. And then distribute, don't forget parentheses. How? 68Q minus 20Q will be 48Q minus 0.1Q squared. Well, I should have put it at the beginning, but this matter. This is my profit function. Did not differentiate anything. I just found profit function. Now, maximize the profit. B, so that's step one. Step two, find derivative set equal to 0. That's exactly how we find maximum minimum. We just did that. Find a derivative, 48 minus 0.2Q minus 0. Set it equal to 0, and you have one critical point. And since it's the only critical point we have, and the profit was increasing and decreasing after that, that will give you the maximum. Solve for Q. Q, do you know what to solve? 0.2. Q equals 48 divided by 48. Careful solving it. Q will be 48 over 0.2. But divided by 0.2 means multiplying by 5, I think. So that's 240. So the answer, this is critical point, and that will give you this optimal number of quantities you need to sell in order to get maximum profit. Step 3, plug this amazing Q you just found, 240, into the original. P at 240 is minus 0.1, 240 squared plus 48 times 240 minus 23 gives you $5,737. Answer. Maximum profit is 5737 at Q240. That's one problem. Let me see questions. When we're only given revenue, and then you need to calculate the cost based on some problems from the book. Sometimes you're not given anything and you have to figure out. Remember, you have to like read carefully and stuff. Yeah, you need to practice that too. So I like when it's straightforward, when you just can see what profit is from here. But sometimes you need to read, oh, I'm spending $35 per month, plus the fixed cost 10. That's going to be 35x plus 10, and so on. So you practice these, and actually they will be very important to 11 anyways. But how about this one? One more. I want to show a second one, and I will read more questions. example. What if Q is given minus 10p? This is better. I found a better one. Let me check something quickly. So blah blah. Still good. Yeah, this is a good example. Why not? Q is given as minus 10p plus 422 millions units at selling price of p dollars per unit. Selling price is p units per dollars. Like, what the heck does this mean? What selling price would have resulted in the largest projected annual revenue? Maximize revenue. How about this? Like, no p is given. What the heck does that mean? And what should we do, right? So, solution. Doesn't matter if it's not given. Revenue is still quantity times price. So quantity is given as equation minus 10p plus 42220. And then p is given as p. So you multiply by p, and that gives you quadratic function minus 10p squared plus 4220p. That is my revenue. And then you repeat the whole process. Same thing. Differentiate. Step 1, create a function. Step 2, differentiate minus 20p plus 4220 equals to 0. Solve for p. I'm skipping the step of solving. To $11. Plug it into the original. 3r at 211 will be original one. 211 times 21110 equals 445,210. So answer. Maximum revenue is 44521 at the price $211. Well, that one is also dollars for you to know. Both are dollars. So this is the one to remember how to build the revenue function. Let me check questions. So will those be on the test? Will it be straightforward? If not, could you do an example? I think it's straightforward, but that's the thing. I'm always afraid to say if it's straightforward, and then people feel confused on the test. That's a tricky thing to answer. I cannot tell how straightforward it is because I don't know what is straightforward for students or not. So you need to learn, I would say you need to learn how to build the equation from reading the problem. I think they wanted to do this. How did you get part 3? Plug into the original. Plug into original. And the original was this one in the box. Yeah, plug here. And I just skip calculations. Where did you get 211? 211 is from solving r prime equals to 0. Move minus 220p on the other side, divide by minus 20. Yeah. Something like this. And from there, let's jump into the elasticity demand thing because it's kind of related to all of this. Related to all of this. Do you remember? Let's jump right away. It's in the same chapter anyway. Elasticity demand function. E is minus, do you remember what it is? So it's going to be P over Q, derivative of Q with respect to P. I remember it exactly like this. It's always reversed. You differentiate Q with respect to P, but then they take P and divide by Q, and don't forget the negative sign. But then I will give you this formula, which is very nice of so you don't have to mess up with the formal part. And then fine. So let's call it A and B. A, maximize revenue. B, so we did that. You remember you can also maximize by setting E to be equal to 1, but actually you can maximize the revenue using this. Many people did this. using this formula. Many people did this on the exam and I gave full credit for that. But yeah, E can be 1, less than 1, and greater than 1. And that means something, remember? So do you remember what it means to be greater than 1? Like equal to 1 and less than 1. Equal to 1, it's a unit elasticity, right? Unit elasticity, that's the 1. And then it's going to be either or. Less than 1. How to remember which one is which? You can see people keep being confused. If it's less than 1, then it's weak. That's how I try to explain it. And I think people remember it pretty well after this. And less than 1, right? So it's small. And small means it's weak. And weak means it's not elastic. Being elastic, it's a good property. You want to be flexible to succeed in life and stuff like that. So inelastic means it's weak. It cannot change. And because it's inelastic, you can raise prices and the consumer cannot adapt and will buy it. That's the thing. Consumer is inelastic, cannot change, that's the idea. So raise prices. How did we write it down? If price goes up, come on, erase. If you increase the price, revenue will increase. And if you decrease the price, revenue will decrease. And fix me if I'm wrong. And then greater than 1 means you're cool. And by being cool or strong means you are elastic. You are changing with the world. That makes you stronger. That's how I kind of remember it. I don't know. That means if you increase the price, I will stop buying it because I can adapt and buy something else or make it my own, like grow my own vegetables and stuff. So you should not increase prices too much at least, and so on. So what if they ask you to find, calculate the price elasticity of demand when the price is 10, or like, whatever. Find price, and elasticity of demand. So is demand elastic or not? When, and we give you P is $10, for example, per blah, blah, blah. So do you remember how we do it? We use the formula. You first, step 1, find this derivative of dq with respect to P. Go back to the Q equation. Q equation is over here. And differentiate that. Well, it's going to lame, okay, it's going to lame in this case, it's just a number, minus 10. Okay, why not? Then build E. E is minus P over Q times dq with respect to P as derivative of Q with respect to P minus P is 10. Well, maybe I should not plug yet. P is P. Q is the equation. Minus 10P plus 4220 multiplied by minus 10 equals plug 10. Actually is a coincidence. I just made up something and then end up to be the same number. Let's choose instead of 10, 20, or else it will be confusing for your notes. Let's plug 20. So minus 10 came from the derivative, and now you plug P equals 20 into your E and see what's going to happen. So it's going to be minus 20 times minus 10 over minus 10 times 20 plus 4220. And I don't know what it is because I just made up all of this. So, but it better be positive. If it's negative, probably we messed up, but I don't think it is. So let's see. It's going to be 200 at the top. 2 zeros. And then and it's going to be 4220 minus 200, like so. 200 over 4020. Nice. Most important, if it's less than 1 or greater than 1, it is less than 1. Less than 1 means weak, means inelastic. Inelastic. Cannot change. Since it's inelastic, $20 is not enough. You can keep raising the price to get more money. People will be still buying it. So it's like a computer. $20 too few. You can raise to 400, for example, and then check again, 500, check again. Oh, became greater than 1. Then you reach the perfect moment. But we also did found that the maximum profit is at 211. We found from the derivative. So, and we know how to also find, you can set E to be 1 and solve for P. And it should give you the same number, by the way. If you take that formula and set it equal to 1. So note, E equals 1, solve for P. This also gives maximized P or maximized revenue. And we found before using different methods. It's the same thing, just two different ways to do it. One comes from derivative set equal to 0 of revenue function. The other one is coming from building E and set equal to 1, because that's unit elasticity. So now we know $20 was not enough, not even close. And it's true because we already found it should be 211. Yeah, so keep raising. Let's see what people ask. Where did you get minus 10p? Oh, minus, it was at the beginning. This one, that was my Q. Formula says P divided by Q. So I divided by minus 10p plus 4220. Oh, and then squared. Squared? I don't see anything squared. This minus 10 came from differentiation of, let me write it down for you, minus 10p plus 4220 prime. Yeah, derivative of Q. That is Q prime base. Q prime. Remember, dq with over dp is notation for derivative of Q with respect to P. And the answer is minus 10. Yeah. I don't see minus 10p squared. So you have to like show me where it is. How about that? So we covered kind of both elasticity and maximizing stuff. More. Let's move on because it's already taking a lot of time. And I unfortunately need to go at some point. So let's do more stuff. Related to rates problems and optimization problems. Review these. I like the simple one with like rectangle box and something which I put before on tests and quizzes. I like those. So optimization problems, like the ones, you know, related rate and optimization problems. Related rates came right after the implicit differentiation because we use implicit differentiation related to rates problem. So related rates, remember my favorite ones are balloon and the circle because it's a sphere and circle. Just check those typical ones, the puddle, the radius of a circular puddle. Puddle is growing at a rate 15 centimeters per second. And I can ask you different things. How fast is the area growing at the instant when the radius is 30? How fast is the area growing when the area is 81? Blah, blah, blah. And I can also ask to find how fast the radius is growing. How fast the radius is growing. No, how fast the area. Radius is given in this case. How fast the area is growing when radius is 30 centimeters. Solution. You know this formula, right? Pi r squared. Pi r squared. So differentiate both sides. That's implicit differentiation. dA over dt equals 2. Let's do next one. Pi 2. Let's call it Fine, capital R, usually it's small r. dr over dt. Now, so step one, differentiate everything. Two related rates show up. Here it is. One is given, one is not. And you just need to figure out from reading which one is given. Radius is growing at the rate 15 per AC slash. So this one is given as 15. Find how fast the area is growing when the radius is 30. Boom. Just plug it in. In this case, left-hand side, exactly the one we need to find. dA over t, plug in. Pi 2 times 30 times 15 and gives you 2827 centimeters squared per second. That is the answer. How about that? Will they give us the formula? But don't you know pi r square formula though? The cubic one we give you and some kind of stuff. Pi r squared, I don't know. I can give if you want, but it's kind of, I think everyone knows pi r squared, right? Yeah. So this was the example. Optimization problems. I like, so check these, check the one with like this balloon was in the exam one, in exam two, I put the balloon, remember, I like it too. And how about, so elasticity, what is that? Blah, blah, blah. Where is the problems of these boxes? Fences? Yeah, maximize the fence, that kind of stuff. You review it by yourself then. Maximize the fence. Those kind of questions are good. Maximize the box, the volume of the box. Specifically, those are review 2 or exam 2. Exam 2. Number 15, very classical one. 16, very classical one. There's a price. Remember, minimize the price of building stuff. That was a classical one. 17. Oh, that's it, kind of. So, an exam. Check exam reviews and quizzes. I also remember giving this in quizzes. Quizzes, like so. Could be question, you can do it by yourself too, because we did it in the review exam 1. I remember posting notes there, and the volume, or else we're not going to get to the integration. So let's go to integration. Let's see if we did everything else. Higher order derivatives, we did that. That was velocity acceleration. Radius, related rates, we did that. Elasticity, we did. Nice. Moving into exam 3 and further than that, and surplus. Exam 3 was about integration. So they want you to be really good in integration. There will be lots of integration problems in the test. Both differentiation and integration. So you should be good at both. Integration of definite integral and indefinite integral. U substitution and integration by parts. Integration. No. So we had indefinite integral, which is like 5 over x dx. That is 5 natural log of x, absolute value, plus c, right? We also have definite integral, like x squared plus square root of x dx. Don't forget to write dx. From 1 to 2, that is definite integral. X cubed over 3 plus, take a pen to rewrite, x to the 1/2. Add 1 to 1/2, that's going to be x to the 3/2 divided by 3/2. Instead of plus c, you have a bar, 1 and 2. Plug, and it should give you a number. So, indefinite, definite, equals, plug 2 everywhere. 2 cubed over 3 plus 2 3/2, not divided by 3/2. Let's multiply by 2/3. 2/3 is multiplied. Go ahead. 2/3 is multiplied by 2 raised to 3/2 minus parentheses, plug 1/3 plus 2/3. Nice. Equals. Take calculator, calculate each collected terms. The answer should be a number. Remember, the difference is the answer of the indefinite integral is a function plus c, and the answer of the definite integral is a number. And it also has a relationship between area between graphs, area below the curve, right? And undoing differentiation. So we learned that, practice lots of integration stuff. We learned U sub, and I put actually notes, hey, do U sub here. And integration, my parts, we learned that too. So you have to practice this. We just did it on the previous exam. And it's going to be there again, basically. For example, let's do this kind of example. How do you do? Let's do several examples. Example 1. From 0. Yeah, would be nice to do both. From 3x squared plus 1, x cubed plus x minus 2 to the 9. Let me check quickly. Nice. From 0 to 1. How do you do that? Use substitution. Find the one you don't like the most and choose that to be u. Usually you don't like something that is raised to the 9th power. Choose that to be u, then you will have u to the 9. And also you can see that u prime, oh, let's not make it so beautifully nice. It's fine. Next example, I will show something more. So this will be perfect. Du, let's check this out. Let u be x cubed plus x minus 2. Du is 3x squared plus 1 dx. That's exactly what we need. We need 3x squared plus 1 dx. Are those dx? And this is what we have. So that's good. Now you either change limits of integration or you don't. If you change limits of integration, u will be plug 0 into the u, equation number 1. 0 plus 0 minus 2 gives you minus 2. Plug 1. 1 plus 1 minus 2 gives you 0. Interesting. That is my u substitution box. New integral becomes from, so 0 became minus 2, 1 became 0, u to the 9 du. That is u to the 10 over 10, and you plug new numbers into u because they have to match. U and u should be plugged into u. That will give you 0 minus, so 0 minus, or put parentheses, that's important, minus 2 to the 10 over 10. So the answer is minus 2 to the 10 over 10, whatever. 10 over 10, which is actually just 2 to the 10 over 10. If you don't change limits of integration, note, then proceed with indefinite integral. You'll have u to the 9 du. You'll have u to the 10 over 10 plus c. And now you go back to the original function. You cannot plug 0 and 1 into u. So you go back to the notation that u was, zoom out, x cubed plus x minus 2. So it's going to be x cubed plus x minus 2 to the 10 over 10 bar from 0 to 1. Now you can plug. It should make sense to plug x into x. That's the point. Plug 1 everywhere. It's going to be 1 plus 1 minus 2 over 10 minus, open parentheses, always use parentheses just in case, 0 plus 0 minus 2 over 10 gives you same answer, 0. Oh, that was to the 10. To the 10. That gives you 0 to the 10 minus 2 to the 10 over 10, the answer is the same. So technically speaking, you can check yourself if you have it. And the best way to check yourself is to differentiate this function before you plug in everything, and it should give you this function we started with. That's the best way to check yourself on the test. Questions? Let's see. Could you do an example of integration by parts? Of course. Do you plug 0 in first or -2? Oh, you always plug. That's a good question. Very good question. You always plug whatever is on the top first. Top minus the bottom. Yeah. That's the rule. Top minus the bottom. So you plug 0 first and then -2, no matter what is there. At some point, there will be functions there. So just plug whatever is in the top function and whatever is on the bottom.
So why did you get rid of the 3x squared plus 1? Like, will it always just be like, you just always get rid of it?
No, that's a good question. That's why next example will show it better. So you do like this. You don't see it yet. Like you ignore it for now. You choose u. You find the u. From there, you need to solve for pieces you need in the integral. Now you go back to the integral and you see that there is 3x plus 3x squared plus 1 dx left after you chose what to call u. But du is the perfect 3x squared plus 1 times dx. So this matches with being called du in blue. And I'll show you example when it's not a perfect match. You don't have to know shortcuts if you don't want to. There's a question in the chat. Do we need to know use sub shortcuts? You always can perform use substitution from scratch. That's fine. Your shortcuts, it's my kind of additional information for students, so they are faster. The off-topic question. Let me show one more example, and I will answer better the question of this 3x squared plus 1 thing. The off-topic question is, it's in the physical science H wing. Whatever is in the announcement, I did not check where it is. I know that I made an announcement that this was correct because I double checked with the department. And now tomorrow I will just check where it is. But yeah, it's a physical science. See if it's PSH, right? Let me see. It's PSH 150. Yeah. Make sure you go early because physical science building is like a maze. It's horrible. Everyone getting lost there. Every time I have finals there, I'm getting lost all the time. You don't need to memorize shortcuts for the test. You just perform or use substitution if you don't remember shortcuts. But if you do, then it's just faster because integral of e to the 7x plus 3 dx is it's not 7, 5x plus 3 divided by 5 plus c. That can be done using your substitution. You choose those to be u and blah, blah, blah. So it's your choice. Do you want it to take more time or not? But your substitution works. Shortcuts all are given in the previous places, and I will give a table. I also have videos on that, so that's very convenient. I can just do that. Let me show one more example with U sub, which will be more interesting and more confusing. So I want to show that. And also, like your question just right now asked about it, so it's very important. 1 and 2. Integral of 15x square root minus x squared plus 7 dx. How about that? That's a u substitution. Nobody likes having stuff instead of the square root, so call this to be u. Let u be minus x squared plus 7. Then du is minus 2x dx. And this is exactly what answers the question before. What to do with 15x dx. So, okay, we have square root of u. I do know that the integral will have now square root of u. But like, what to do with 15x dx? This is how you do it. There's several ways to explain it. And this is the way I think is the best one. Kick out 15 outside because we can. It's a constant, right? So now we only need to define what to do with x dx. Solve for x dx from the line number 2. X dx is minus 1/2 du. I'm dividing by minus 2, right? And now I'm going to plug equation number 1 and equation number 3 into the integral. And this is my u substitution. So 15 is outside, square root of u, and then in yellow, x dx. X dx. That came from the previous equation is minus 1/2 du. Kick out minus 1/2. 15 over, so minus 15 over 2, integral square root of u du. Integrate that. We just did this already, so I will skip some stuff. It's going to be u to the 3/2 divided by 3/2, so times 2/3. Nobody knows what u is, so you have to go back, especially, you remember, indefinite integral gives you function, so you have to go back to the previous notation. 2 cancels out with 2. Minus 15 over 3 is minus 5. So it is just minus 5. U is minus x squared plus 7 raised to the 3/2. And this is the answer. Can you do that? Let me check. And did I answer the question before? Like, about that part. The last time, it was a perfect match with du, so we never needed to solve for anything. This time, it was not a perfect match. I needed x dx to be gone, substituted with some kind of du thing. So I used this equation number 2 to solve for x dx, and that became negative 1/2 du, and I plugged it in blue. How about that? What do you think about this? This is U sub examples. Yeah. If I ask you to find the average function, do you know what to do? We just did it in exam 3. Divide by the length of the interval. Okay, let me check questions. Is the final exam review on the web assigned for extra credit? Yes. It will close soon though, so you should hurry up. So let's see. More, I wanted to show you this stuff. So lots of integration, fundamental theorem of calculus, applying the top minus the bottom, we just did. Let's see. You guys liked, I think, the left Riemann sums and right Riemann sums, because this was like one of the biggest average problem on a test. So I put it there. I was like, if you people did good, why not to put it there? So let's review Riemann sums. So I would say it this way, the coordinator put it there, and then I was debating which one is the good to kick out. And I thought like this is the good one to keep because people did pretty well on this on previous exam. Riemann sums. We have left Riemann sums, RL, and right Riemann sums. No, we call them like left 5 or whatever the number is. So what's things to remember? Remember then that the step size at delta x is b minus a over n. It is your step size, which is, here is the interval. It have points. How many of them? How many, not points, how many intervals? That's n intervals, n intervals. On the example, it's easy to understand. Delta x is a step size. Delta x, delta x, delta x. So you take the whole interval from a to b and divide by number of intervals, in this case 4. And then you ask you to find left Riemann sum. Left Riemann sum, it will be delta x. Factor it out, don't have to put brackets. F at, how did we call it? A was called x sub 0, right? X sub 0 plus f x1 plus f x2 plus, and then you have to kick out the last one, x n minus 1. So have to kick out. You only, visually it looks like this. Using, not using. So using, not using the right endpoint. Left endpoint means you start everything from the left, so the right one should be kicked out, the very last one. Right endpoints. Right endpoints. Riemann sums. Delta x, you skip the first one. So visually, it looks like this. Skip. Come on. Skip, using, like so. So you skip the first one, and then you start with x1, x2, and then you go to the last one, x sub n. And that's what's called right. Why did I put the brackets? That's why I called right Riemann sums, because they're using the right endpoint. Example. So two ways we taught you using integral or using a function. And it's the same thing, to be honest. Just a bit visually, it's different. But other than that, it's fine. For example, but you should know both. Either I give you an integral or I give you a function. Oh, let me check the questions about theory. So Riemann sums won't be on the test because you kicked it out. No, that's not what I said. I said that you guys liked Riemann sums, so it is there. Yeah. Here you go. Example 1. Either I give you the function, kind of like check exam 3. I gave lots of notes there in solutions. 3x squared plus 2x minus 3 over 1, 2, 3, n equals 5. Use left Riemann sums. Okay, let's do that. Solution, step 1. That's what I even help you to start, remember? Find delta x. 3 minus 1 over 5 gives you 0.4. Boom, after this, you can start writing down. Riemann, also left 5 is, or like left Riemann sum, LRS is good too. Delta x 0.4, f at, and I usually make a sketch. So we're starting at 1 and we're ending at 3. We have 5 intervals, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 0.4, 1.4, 1.8, 2.2, 2. Glitched for a second. 6. Let's just glitch for a second. So you plug in f plus 1, f plus 1.4. So we're using only the left ones, right? And we kick out the 3. We don't need that. F at 1.8, f at 2.2. F at 2.6, and then how do you find them? You plug them into the function f. You plug them into the original. Calculate the numbers carefully, and it gives you 256. How about the integral notation? 2. So I will show you 2 questions, and then you ask. You also have this nice example over there with the integral. Let's do for chance, right? Riemann sum. Like also we're discriminating all the time. Using right. So right Riemann sum, RRS, that's not an international notation, that's a must. Right Riemann sum, interesting. Right. And n equals 4 subinterval to estimate the definite integral. To estimate. And that's one of the beautiful applications of those Riemann sums and approximation theory, that sometimes you cannot use, not the U substitution, not integration by parts, nothing else. So you use this, called numerical approximation or Riemann sums approximation. Lots of different methods to approximate. So there's no equal sign. Kind of we know how to calculate this integral, it's U substitution, logarithmic functions and stuff. But if there's more complicated case, you don't know, so you have to do that. Okay, step 1. Step 1, delta x is 3 minus 2 over 4. It is 0.25. And you can start, make a sketch. We are working from 2 to 3. I see it from the integral, see? That's where I got 3 and 2 from. It's the interval of integration. So that's the interval we're using. We have 4 intervals, 1, 2, 3, 4. And the step size is 0.25, so it's going to be 225, 2.5, 275, and 3. write Riemann sums with skipping the first one and going to the last. So step 2, let's start building the thing. Write sub 4 or RRS will be factor out 0.25 and then plug into your function. So let me write it down. 1 over 1 plus 2 times 225, plug into the function, okay? 1 over 1 plus 2 times 2.5. 1 over 1 plus 2 times 2.75. And finally, 1 over 1 plus 2 times 3. Calculate that, whatever it is. Can you do that? Can you do that? So like those two, like very classical problems. Let me put this in a circle. 1 and 2. Step 1, step 2. It has 2 steps basically. Or maybe step 3 is grabbing a calculator, which you should not forget for the test, and actually calculating all of this. Let's see. Keep going. Don't sleep. Keep going. We did this. We did lots of stuff. It's very successful, actually. We're almost done, so stay strong. Good job for staying strong. We did this. Ooh, it's very good. Integrals, average function. Yeah. You know, average function. Oh, we should do integration by parts. Yeah, that's the one we should do. Integration by parts. Let's find it. Oh, also remember initial value problem. Now let's do that. And integration by parts. Let's do first integration by parts, since it's like a classical technique. A classical thing for integration by parts is this number 14 from the review. Integration by parts. So integral u dv equals uv minus integral v du. Some of you actually using the formula, which is very cool. I always learn it as a student. I remember I learned it visually from the box, how to do it, diagonal in the bottom, but you know, anything works if it's correct. So integral of x squared ln x dx. Remember integration by parts and thus product rule of two functions if you have no relationship between each other. Well, change ln while use substitution and thus change. Liate. Choose u if you see first log. Let me change the color. If you see log, choose that to be u. If there's no log, inverse functions. We did not cover them in this class, so don't care about that. Algebra. If there's no log, no inverse, choose algebra. If there's no log inverse in algebra, choose trigonometric functions, which is again, we completely skipped, which is kind of weird. And then exponential function is your last choice. So I see algebra, that's x squared, and I see log. Which one should I choose? Liate tells me that log is the best choice. If it shows up, it should be the first one to be chosen because you don't want to integrate log. You either differentiating or integrating in integration by parts process. So u is ln, du is 1 over x dx. Now take whatever is left. So this is u. This doesn't have a choice anymore. That will be dv. dv will be integrated, and that's why you don't want it to be log. That's actually also a good hint. dv. V is the integral of dv, so it's x cubed over 3. Don't need to write plus c. Cross product minus bottom equal. Should I do different integrals? Yeah, let's practice different integral. Let's make it from 1 to 2, so we can plug stuff. Remember, we don't change limits of integration for the integration by parts process. ln x times x cubed over 3 bar from 1 to 2. minus is part of the formula. It's in the box. Let me zoom out. U times V we did minus integral bottom, product of the bottom ones, x cubed times 3 times 1 over x dx, like so, from 1 to 2. The first piece is ready to be calculated. Plug the top minus the bottom. ln of 2 cube over 3 minus ln of 1, which is 0, 1 cube of 3. That is the result of the first piece. Minus, put huge fat minus. Simplify the integral from 1 to 2. X cubed over x is x squared over 3 dx. This one have to be integrated. So this is 0 for you to know, because ln of 1 is 0. ln of 2 times 2 cubed over 3, that's a number, minus integrating x squared over 3 gives you x cubed over 3 times 3, which is 9, a bar from 1 to 2. Finally, plug the numbers and you get the answer. ln 2 cubed over 3 minus, open parentheses, or else you will mess up the sign. Plug 2 cubed over 9 minus plug 1 over 9. Distribute the negative sign or calculate whatever it is. 2 times 2 times 2. 8 over 9 minus 1 over 9. Actually, you can just calculate it first. 8 over 9 minus 1 over 9 is 7 over 9. So the answer will be ln of 2 cubed over 3 minus 7 over 9. Remember, the answer for the definite integral is a number. How did I get 9? So this way. Let me show it here. Integral of x cubed is x 3 over 3. And then 3 times 3 is 9. I could write it down if you want. 3 times 3. And then how you do the derivative of u, how do you get 2/3? 2/3. Oh, good question. Plug 2 into x. So it was 2. I think that's what the one you're asking, right? 2 cubed over 3, and then 1 cubed when you plug 1. Cube over 3. For the integral, I mean the integral when it is x squared. Let me find. Oh, this one. X cubed. X squared. So x squared is dv. I'm integrating x squared. It becomes x cubed over 3. U times v gives me this part. Minus v times du gives me this part instead of the integral. X cubed over 3 times 1x over x dx. Does that answer the question? There are too many places that has x squared over 3, so I don't know which one you're asking. So that's just a guess. Let me know. Integration by parts. Okay, keep looking. Let me know. And I will do. We're almost done. Good questions, people. Integration by parts, area between curves. Did you review that? To be honest, whatever I put in exam 3 was very good. So average value. Take the integral, divide by the length of the interval. And then the last topics was the surplus, and we kicked out improper integrals, which is not the best topic, but it's kind of annoying to put it and stuff like that. So let's do what I wanted to do. I wanted to do initial value problem. Integration by parts. Everyone liked the initial value problem. People did a magically really good work, except the one that messed up, the one with the year. Remember, there was, like I said, check the problems that gives you some year, 2004, 2007. Somehow people don't understand little bit of that backstory. So let me practice that. Yeah, 12, number 12. The YouTube became available in public in 2005, and the rate at which the videos have been uploaded to the since approximated the function, blah, blah. 12. That is exam 3 review, or just check exam 3, to be honest, it's also good. And I also put it on the quiz. It was quiz 8, I think. So we give you a function 1.1 t squared minus 2.6 t. Okay, that's not initial value problem, I just realized. Initial value problem comes after this. This is just definite integral. T is a time since 2005. Use a definite integral to estimate total number of hours. So this is the rate, right? So rate means this is a derivative of a function. Then they tell you find total number of hours when this is the rate of hours, blah, 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 videos per hours from, and then we give you the range 2007 to 2010. What is your job? Is to integrate solution. Integrate from 2 to 5, 1.1 t squared minus 2.6 t plus 2.3. Check my notes. When I was grading your exam, I gave you notes like how to do it. Because 205 is your 0.207 is 0.2 on the x-axis, if you think about it. So basically what they do, they put 205 over here at the 0 point. So 207 will be 2, and then 2010 will be 5, like so. Makes sense. So it's integral from 2 to 5. And then you integrate, plug in, blah, blah, blah. So you got it, This is good. And the option. Integration by parts. Everyone did really well. Integration by parts no, initial value problem. That's the one when we give you some kind of value. For example, the most popular one, we give you marginal. No, when we give you velocity and you need to find velocity. Velocity is given v of t minus t squared plus 8. And we know that s of not put zeros, s at 2 is 10. So find s at t. Yeah, my tablet's dying. That's one thing, we cannot stay longer than 2 hours. But a little bit more it should stay. So solution. Step 1, this is called initial value problem because initial value is given. S was found by differentiating. V was found by differentiating S. So you will integrate V of t dt with respect to t. Integral of minus t squared plus 8 dt equals minus t cubed over 3 plus 8t plus c. This gives you a family of solutions, but we don't need a family of solutions. We want one specific solution. So we're gonna use this information. At 2, it should be 10. That means 10 equals minus 2 cubed over 3 plus 8 times 2 plus c. Solve for c. And give the answer with the exact c, because it's exact solution. C is 10 plus 2 times 2 times 2 is 8 thirds minus 16, whatever it is, minus 6 plus 8 over 3 is minus 16. I need to do it in Russian. Minus 18 plus 8, minus 10 thirds here. Answer. s of t was chosen to be minus t cubed over 3 plus 8t minus 10 thirds. This is correct. Do you remember that? Everything did really well in this problem. Almost everyone did really well in this problem. Initial value problem. Then that's what we give you initial value. For example, we give you marginal cost and we ask you to find costs, but we give you that original cost function at 5 or 17. Same story, but you just repeat. Area between curves, let's review that. There are two more things actually left only. Area between curves and the very last one, surplus. Area between curves is something like this. Yeah. One of the applications of the integration was, see when I'm charging it, it doesn't work. Area between curves. So examples. Yeah, this is a good one. This can be both multiple choice or free response question. So definitely check the review. The review have both actually. Review 3 has both, so it's nice to practice. Number 15 is find the area between curves given by minus x squared plus 6x plus 2, y equals 2x squared plus 9x minus 4. And I also gave it on the exam. So between those two curves, either you use your graphing calculator and a really fast sketch to see, you need to see which one is in the top and which one is at the bottom, because it will be integral from a to b, top minus the bottom, dx. So since this negative makes the parabola looking concave down, which is Z1, remember? This is Z1. So it's literally a parabola that looks like this. And this parabola is concave up, so it's a happy one. Then you know which one on top and which one on the bottom. How else they will create the area. So the one that's looking down will always go first in these types of questions. So, or you sketch the graph using graphing calculator. One looks like this. Let's call it number 1. And the other one looks like this. That will be number 2. Happy minus sad. No, happy versus sad one. So who is one? Which one is at the top? Number 1 is at the top. Before putting them in order, green, bottom. Number 2 is at the bottom. We need to find points of intersection. So points of intersection. I thought it will be intersection. I thought it will be a very nice problem on test. And then many people just stuck solving quadratic equation. It was upsetting because I thought that would be like good points to give people. Minus x squared plus 6x plus 2 equals 2x squared plus 9x minus 4. Find points of intersection, set those two equal to each other. Move everything to the left-hand side, see what's going to happen, or the right-hand side. 2x squared plus x squared gives you 3x squared, 9x minus 6x, 3x, minus 4 minus 2 minus 6 equals to 0. Quadratic equation. I can divide by 3 if I want to. X squared plus x minus 2 equals to 0. X plus 2 and x minus 1, or use quadratic formula again, wherever you know, but you need to learn how to solve this. Learn this. It's going to be on the test again and again next semester. So those are my points of intersection, minus 2 and 1. They should also look nice on the graph. It's true. See, it looks nice. Minus 1, minus 2 and 1. They kind of make sense. Step 2, finally write down the integral. Integral from minus 2 to 1. The function at the top is the one that is Z1 minus x squared plus 6x plus 2, come keep down, minus 2x squared plus 9x minus 4, that's come keep up. Simplify, integrate. I will skip some steps Integral from -2 to 1, minus 3x squared minus 3x plus 6 dx. Integrate minus x cubed over 3 cancels out 3, minus 3x squared over 2 plus 6x bar minus 2 and 1. Start with plugging 1 everywhere. Minus 1 minus 3 halves plus 6 minus. Start plugging minus 2 everywhere. Careful with signs. It will be very important here. Minus 2 cubed is minus 8. But minus 2 squared is 4 squared cubed. 6 minus 2. Huge parentheses matter because you'll mess up with signs. Calculate one piece carefully. Calculate another piece carefully. And you will get positive number because it's the area. Positive. See? What do you think about this? How much now? 17%. Oh, it's gonna die. So this is good. And let's quickly review formulas for surplus, and I think we're done. Will we be tested on area? Yes, maybe. So that I'm reviewing that. So you will give both equations in the test. What equations? On a test. Which equations? We have many. Oh, y equals, I mean, sometimes those equations, sometimes they're called x's, x. So these, one of them might be given, the other one may be x-axis or y-axis. So the answer is not really, kind of depends on the problem. Yeah. Finally, last review goes to the review 14.4. Let's do that, still enough time to do that. Your shop can sell 50 I love calculus t-shirts. That's the example. That is so optimistic. Okay, so let's review that. Last topics. Will this review be uploaded tonight? Yes, but the longer the review is, the longer it takes for video to be created. So I'm pretty sure it will be done like in 3 hours. Then I can upload it. And it's because it's a very long video already. Surplus. Surplus. Which is which one? Consumer and supplier. CS, PS. I gave you nice formulas. Remember which one comes where? But then I just decided to give it to you on the test. So like, consumer surplus. I remember that CS is the cool one because it starts with the function. Demand function. And then minus P. DQ. And then PS starts with P minus the function. So kind of that's how I memorized. I don't know, you choose how you memorized. And it's from 0 to Q bar and P bar. And then PS starts with P minus the function. P bar again. P bar minus the function. And this function now is supply equation. DQ from 0 to Q bar. So boom. This is an exam already there because it's a new thing we have to cover. So you guys stuck with solving equations. That's the problem. Like you might be amazing with everything, but if you cannot solve the equation, you'll mess up solving the equation. That's why I have several videos. I made videos for you right when you show me that you're stuck with this. Let's do it. Let's do logarithmic equation and the formula thingy. Which one is better? Let's do the one that they ask equilibrium price. So total social gain, total social gain. We call it total surplus. I don't know why they are so fancy. CS plus. I checked several books. And some of them never call it total social gain, but some of them call it both. Total surplus and total social gain. Just add together. Example. So they were examples when they ask you to find everything. Let's find everything. Consumer surplus, producer surplus in add together. The backstory number 3, that's final exam review. Final review, and you will have it in your review and homework as well. So let's do it. A company finds that the demand for the product is given by P is 13 minus Q1 fourth. And that is a demand equation. That is important because you need to know which one to put in which formula as demand. P is the price per item and Q is numbers of items can be sold per week. The company is prepared to sell. Supply equation S is Q equals P minus 4 over 2 to the 4 items per week. Find the equilibrium price P in the consumers and producer surplus at the equilibrium price. Equilibrium price is this the bar thing. Equilibrium price and equilibrium quantity. That is the P bar and Q bar. That's what they mean. But basically, yeah, something is missing. So they wanted to solve and find both. So let's do it. The equilibrium price can be found by solving the system. P equals, and yeah, some of you complained, which I can agree with. I was checking the solutions in your homework. They watch me videos and they skipped steps how to solve equations. And to be honest, they made it more confusing by skipping those steps, which was kind of rude. Like, why would you skip? If you're already making solution, make it good. But basically, they want you to solve the system. 1 over 4. So when I was making YouTube videos for you, I did not skip any steps. I showed you everything. Let's to the 4. Yeah. This is 2. So this you should solve the system. How you do that? Plug one thing into another thing. See, they actually said it. Either plug P into here or plug Q into here. It's called substitution methods, solving of system of equations. We teach it in pre-calculus class. It's called substitution method. We also have elimination method. So let's plug Q into P. Then again, P will be 13 minus P minus 4 over 2 to the 4 raised to the 1/4. And that's why they made it like so. 1/4 cancels out with 4. So from here, P equals 13 minus a fraction, P minus 4 over 2. Now we can solve for P. Actually, the solution in the review is really detailed. I'm very impressed. Someone put effort to type it in. It's going to be, there's several ways to solve it. Maybe you multiply by 2 everything if you don't like fractions. 2P is 26 minus P minus 4, but put parentheses. 2P equals 26 minus P plus 4. 2P minus 26 plus P minus 4 equals to 0. Solve for P. 3P equals 30. Nice. P is 10. And that is P bar. That's called equilibrium. U-I-L-I-B-R-I-U-M. Yeah, equilibrium price. If we know equilibrium price, guess what now? So it was step 1. Step 1, find equilibrium price. Step 2, now we can find Q bar. Q bar will be, just choose any of those equations, it will give you the right answer. For example, equation number 2, P minus 4 over 2 to the 4. That is Q bar. 10 minus 4 is 6, 6 over 2 is 3, 3 to the 4 is 81. That's equilibrium unit. Or I don't know, fine, quantity, let's use quantity, but it's fine. Step 3, now we know that integral will be from 0 to 81, that was important. Now we can start building both functions. Consumer surplus is the one that has function first. From 0 to 81, function goes first. Which function? Demand function. Let's go find demand function. It's here in the box. 13 minus q to the 1/4. 13 minus q to the 1/4 minus p bar. P bar we found is 10 dq. Integrate, that's just power rule, so I will skip and I will get $48.6. That's power rule, there's nothing, no chain rules and stuff. Produces surplus, PS, is the one that function goes second. 10 minus, then supply function, and supply function is this one. This function, this will require chain. You can avoid in general if you want, but still. So it's going to be 10 minus, it's going to be p minus 4/2 to the 4. No. Yeah, that's wrong. Do you know why? Because we need to plug p. We need to plug p equals and not q equals. So we need to solve. Yeah, I see. That's why there will be no chain rule. We need to solve for p from q equals p minus 4/2 to the 4. How do you do that? Raise both sides to 1/4 to undo the 4th power. So q to the 1/4 equals p minus 4/2 multiplied by 2. It's going to be 2q to the 1/4 equals p minus 4. Add 4. It's going to be p equals 2q to the 1/4 plus 4. This is the function. This is supply function. Plug that into the integral. PS is integral from 0 to 81. 10 minus this new thing we just found. 2q to the 1/4 plus 4 dq. That's again a power rule. $97.2. Finally, add them together and give you total social gain. Answer. PS plus CS gives you whatever it is, CS 145.8. That is total social gain. Total social gain. Cool. I think we covered everything. Let's see questions. Could you explain why you changed the supply function? Yeah. The formula says over here. Here it is. Go. Okay. The formula says you should use P in both integrals, but it was never given as P. For this equation, it was given as P. For this equation, P was hidden. So actually, they never gave us P, blah, blah, blah. So that's why I had to solve for P. You don't plug Q into the integral. Yeah, that's what. Yeah. That was the extra step. And let me tell you, last thing is average function. So we found average rate of change right at the beginning of this review, right? But average function, so like it was in test as well, like f of x equals, and let me review one more chain for you, because we know, or one more integration by parts. Let's do one more integration by parts. I think it still confuses you. Oh, that's a chain rule is better. Somehow I feel like chain rule confuses people more than integration by parts, which is common. I told you, my calculus 2 students are also still struggling. This one. Yeah, this is a good one. 4x e to the x squared minus 3. Find the average. Find average. On, let's say, 1, 3. What do? The formula is integral from a to b, f of x dx, that's normal integral, but in 1 over b minus a, that is average integral, average function. So you integrate integral 4x e to the x cubed minus 3. You can even find just definite integral first if you want, or not. You can just figure out everything right away. From 1 to 3, 1 over 3 minus 1. So it's 1/2. 3 minus 1. So it's 1/2. 1/2 definite integral from 1 to 3, 4x e to the x cubed minus 3 dx. This should be done using u substitution. Choose exponent to be u. Let u be x cubed minus 3. Then du is 3x squared dx. Now look at my way again. I will explain it again. Kick out this 4, move it outside. So you will have 1/2 times 4 integral. Now you just need to find x dx. That was u substitution. It wasn't u substitution. Let me make it x squared. Change it to x squared. That was integration by parts problem, apparently. Oh, I see. Yeah, I changed x squared to x cubed. That's why. So erase this. Look at this. Look at this. Nobody told me. See, it's very too late for me already to talk and write. It was squared originally, and then I somehow changed it to cube. If it's squared, it works. So fix it to squared, like so. U is x squared minus 3. Du is 2x dx. You need x dx. So let's find x dx. Divide by 2 your du. So now I will have x dx being 1/2 du. Plug equation number 1 in equation number 3 into the integral. You also should change limits of integrations, or don't. Many of you don't do it, so I guess let's not do it if you don't do it. But then don't write limits of integration. That's the thing. Don't write any. It's kind of not correct to write wrong ones. 1/2 times 4. 4 was kicked out, remember? I just kicked it out. Integral e to the u du. E to the u, that's the whole point, and x dx is du over 2, like so. Kick out this over 2 thing. That's going to be 1/2 times 4 times 1/2 integral e to the u du. Integrate that. So remember, the first 1/2 came because it's average. 4 was in the integral, and the second 1/2 came from the du over 2 part. Simplify them all. It's actually just 1, funny. And then it's going to be e to the u plus c, right? But now you go back, plus c. You go back to the original notation. E to the u is actually e to the x squared minus 3, a bar from 1 to 3. Plug 3, e to the 9 minus 3, minus plug 1. 1 minus 3. And that is the answer. The average rate, the average integral is e to the 6 minus e to the minus 2, which is some kind of number, whatever. It is exact answer, and you can check the calculations if you want. That was a lot of writing and talking for 2.5 hours. What do you think about this? We kind of covered the whole semester, if you think about it. We missed a couple small topics, but I think we covered everything. I just followed all the chapters, see? So, very good. Good job, people. Last moment questions?
What homework is due tonight?
You're asking me this technical question. Do you think I remember? Let me check. Since you're asking, I can go check. So the tonight, I think, is a review. That's it.
Is it just a review on WebAssign?
Yeah, I think just review. No, and in Gradescope. So you need to submit your work to Gradescope to get full credit, extra credit. So I will give
Oh.
extra credit on your web work. That's why you could notice, maybe if you didn't, I will make announcements soon.
Okay, but there's no actual homework that's in for a grade due tonight.
No, that's all. So what I did for the exam review 1, 2, and 3, I made them be equal 0 points, but people already got their points. Say it was like 95 points. So it's pretty cool that it counts at 0 points, but you get 98, 96 points, and that 96 points became extra credit. So that's what I plan to do. It's by the night, you finish your final review, I'll make it 0 points, and that will be extra credit. But you need to submit it to Gradescope to get also credit for writing it down. So I'm waiting for that to be done to assign those extra credits. Yeah, that's why I did not update homework program, homework grade yet, because I'm waiting for this to be all done, which is by tonight. So the most important review you can do is the WebAssign review from the website, which I posted, and this one, the one I just did. Could you go over the note pack of elasticity? What is a note pack? I don't remember that. This will be posted tonight. What note pack? Oh, note part. It was in red. And let's see. Have a good night. Yes, let me show this very fast, and then my computer will die, so we better hurry on. And I need to eat also. I'm not an evening person, so I'm very sleepy. Let's see, elasticity. Where is it? Oh, it was differentiation thingy. Yeah. Elasticity minus P over Q dq. I will give those for minus P over Q dq over dp greater than 1, less than 1, or equal to 1. So we give you. What did we give you? We give you this formula Q, a relationship between Q and P, right? For the elasticity, you need to differentiate Q equation with respect to P. I did that. And then multiply by minus P over Q. And then we tell you, well, what do you think is going to be? Is it elastic or inelastic if we're going to sell cups for the computers, $20 each? Plug in $20 and then see the sign. Yeah, the answer. Is it less than 1, bigger than or greater than 1? Greater than 1, less than 1, equal to 1. 3 different ideas. So you need to remember which one means what. And then in our case, it was inelastic. So it says, yeah, you can raise the price, people will still buy it. Oh, note. Oh, I found. That one is, remember we find out that you can maximize. Revenue, not only by finding a derivative set it equal to 0. That is way one. The new way, which comes from way 1. If you remember, I was deriving it in front of you. It was kind of boring, but it explains why it is. You can find E instead and set it equal to 0, not 0, to 1. And from there, you solve for P. See, there's P here. You solve for P. So check our examples in class, and there was an example in the exam. You can use way 1. When I was grading exam, I thought I saw many people use one way, many people use second way. Whatever your brain gives you, that's what you do. To be honest, I use the first way, but it's because I'm a mathematician and I like the differentiation more. I like this idea. So kind of this is the way I knew. And in this way I learned only when I was teaching business calculus class. I learned that apparently there's something called elasticity demand. Nobody knows it until you get into business class. And apparently when it's 1, it gives you maximum profit. Maximum revenue, right? So that's how you can find what P gives you maximum revenue by setting equal to 1. And those are correct, so I don't care which way you do, if it's correct. We would need to be tested in log functions for derivatives, anti-derivatives, all kind of integration, differentiation. You should be good at this, yeah. might be there. There's lots of derivatives and integrals in the test. So definitely prepare these. Thank you. Good questions. Good job. Good job, people. Study hard, and I hope you will do good. I will see you tomorrow. Make sure you have some snacks, sleep enough, or at least have some coffee. Concentrate, don't make mistakes, and have a good night. I will post this review tonight and all the notes for you, so I'll have this PDF file. I'll see you tomorrow, people. Good job. Thank you.